Hey everybody, I'm William Graber. This is for Module 1 for ACTE 655. So a little bit about me. I currently teach high school math at Donegal High School in Mount Joy. I've had experience with teaching Algebra 1, Algebra 2, and a little bit of trigonometry. This is my second year there and my second year of teaching out of college. So I am younger and right out of college. My interest with STEM came from two things. The first was the Junior Achievement STEM Summit, which is a free program that Donegal utilized last year and then this year, and I was a part of that. And it really helped me see how exciting STEM can be, especially for someone that teaches a part of STEM. And additionally, teaching math, I really want to be able to connect the math that I teach to a lot more applications in the real world and where students are able to use that. So personally, I'm married. My wife and I are coming up on 2 years of marriage, and we love to travel. It's just us, no kids at this point. And this is a picture of us in the Finger Lakes. Just recently, we were there, I think 2 weekends ago. It's beautiful if you ever get the chance. We have a very close family on both sides. Her family and my family are always doing something. So it keeps us busy, and it's a lot of fun. We also love to play sports. I personally like to play pickup sports, basketball, soccer, softball. I'm a part of a church league softball team in the summer, and then also in the fall, I'm a part of a softball team. And I love to play games, board games, video games, and I'm all about the superheroes, whether it's TV shows or movies. I can watch it all. So for STEM, my definition of STEM is similar to the definition that I read in the chapters that we had to go through, but the chapters said it better than I think I ever could. It's basically just tying all of the 4 subjects within STEM, science, technology, engineering, and mathematics, together to break down the barriers, as the text said, so that you're getting all of those into one rather than just saying this is a math class and teaching about math and no relation being had between science, technology, or engineering. Rather, now with STEM, it's tying them all together to make students see how integrated those can be, but how applicable they are to the real world. Which is why it's important. Going to the next question, doing that trains the minds of students and creates them to be problem solvers, which is what the world needs. And as educators, I feel that we should focus on bettering students to have a positive contribution to society when they get out of high school or any situation. And to do that is to create them to be problem solvers. And that's what these 4 subjects, my subject specifically math, does. And as Neil deGrasse Tyson said, it changes the wiring in your brain so that you become a problem solver, which is what the world needs. It's not saying that everybody has to be a scientist. It's saying that people need to know how to see a problem and approach it in many different ways. And I thought that was neat how he worded that. And I agree with that emphasis on that. Personally, I haven't used STEM too much in my classroom. I did one project very briefly. It was a project about tsunamis where students were given different coordinates and told kind of the backstory of tsunamis and how they happen and how scientists can predict when they will impact a certain city. So students acted as these scientists, and they looked at where the tsunamis began and how much time the city would have to evacuate based on the depth of the earthquake in the ocean and the speed resulting in the tsunami. And this came from a unit with radical equations, so that wave speed formula is very applicable. They also had to convert things, and that leads into the STEM practices. They had to ask a lot of questions because I didn't give them too much information. They had to figure out how to take longitude and latitude and convert it into actual distance so they can see the distance between the city and the starting point of the tsunami. They had to be able to figure out how to measure that on a map, how to use a compass to see the radius of the impact. They also had to then predict and use computational skills to figure out the time and the speed of the tsunami and then communicate that. So once you figure something out, you have to be able to communicate it to essentially get those people out of that city in a timely manner. And so all the check marks there are where it applies. But as a result, the goals of the course, or for this course, for me specifically, is the K through 12 education video really talked about how connecting the different subjects of STEM is key for students to learn. And I really want to be able to do that and do that well. And I hope to be able to get that from this class. And then understand how to effectively create problem or project-based assessments through the use of STEM. My school has a big emphasis on that right now, and I'd like to get better at that if I can. And then the last thing is to focus on the 5 principles and improve my skills with them that were talked about in chapter 3 of the text that we read. I really liked the last 2 of those 5 principles: challenge your students and mix it up. I feel that students can always be challenged, and they enjoy a challenge if you're motivating them and pushing them to exceed their expectations. And also mix it up. Don't keep doing the same thing over and over again. Get the kids excited about coming into your class. And yeah, those are my 3 goals as of now. I'm sure they'll change, and there'll be more things that I want to learn about once we read and get into things. But I'm excited to go through this class. So thanks for watching.